Any more? Any? What question was I looking at before? What was the question? Okay, if we've forgotten, please. So that's Shimosa. You were saying that we have red representative vegetation. Why? Because red, blue, green, okay, is something that your system is actually assigning. Are you okay? It measures red, but the algorithm in your phone can change the red to blue. Are you aware? Maybe you're not using Snap. If you're using Snap, you can actually look more beautiful than you actually look. Yeah. Okay, Gabriel, ask your question.
Yes, sir.
Ask your question.
Oh, no, sir, it's not a question.
Contribution.
No, sir. No, sir.
Okay, wait. That's fine.
A contribution on what you were saying.
Okay, go ahead. Go ahead. Yeah, oh, yes.
About the camera.
Go ahead.
There are some camera. Even if you are not nice, after you being taking the camera, you look more beautiful. So, like you are saying,
how does that relate to the remote sensing? I'm just using these analogies so that you understand. How does that relate to remote sensing? Help us, Gabriel. What do I really want you to understand? That's why I said that. So because we can measure infrared, when we measure the infrared, how can we see it as human beings? That's a question. Because infrared actually does well in measuring heat. So where there's a lot of heat and high temperature, if you have a sensor which is infrared, it will now sense a lot of it. That I see that these values are now okay. So the reflectance, if you like, becomes better for infrared. Any system that measures infrared. Okay, heat. Once you've obtained values for that, what color are you going to use to represent that? You can use any color. Right? Computers do that magic for us. Are you okay? Okay, wait. So that's it. Remote sensing goes beyond your normal picture. Do you agree with me? The sensor is actually up in the sky on what platform? What platform? What I mean is platform. Platform. On what platform is it? Most the actual sensor on the satellites. The satellites. This is a quiz for you. The satellite. So let me tell you how satellites are launched. They are packed into a rocket. Is that okay? Then they count 3, 2, 1. And if your father is inside, you are praying for him. You pray that in about 3 minutes, no explosion anywhere around the area, of course. Then once it gets out, the module starts separating. Then it's been calculated. The projectile has been calculated. That's one of the reasons why in physics class we're learning projectiles. An object has been thrown. Okay, great. Thank you very much. So yeah. When the satellite gets into orbit, they become space debris. After some missions, the satellite stays up for 5 years, 10 years. Then after that, they are decommissioned. They don't work again because now the flaps are okay. They are what we call how to get electricity with the sun. That's what's it called? Solar. So they have solar panels. Most satellites have solar panels that power the batteries. So they are rechargeable batteries, which will die after some years. That's why they're able to calculate that this satellite will have to come off. Are you okay? So they send it, they become what we call space debris. People suspect that this space debris could actually hit one day, just come to the ground and just hit someone. Yes.
So it's hanging out there.
Yes.
So it's not the same one that we said some stars are coming.
Yeah, people have all sort of theories. There are conspiracy theories. Are you okay? About some of these things. But there's what we call space debris, which means that all the things that have been thrown out there,
it's still hanging there.
They are hanging in there. And if they hit you, that's it. Have you played a game where you have everybody's moving around and something little just hits and explodes? That's the idea. All right, great. So remember the word resolution. Is that okay? Remember that the sensor has channels. Are you okay? The channels are really bands of wavelengths. Is that okay? In other words, when we say red, we have red and we have red. Are you okay? We have the Asante Kotoko red, and we have the red, other type, this one. Are you okay? Someone even call this red, isn't it? It's a kind of shade of it. Are you okay? It's wine. Okay. So let's take note of the fact that we actually can do more than just the visible colors. Are you okay? Can do more than that. I even heard that remote sensing can detect rats in the night. Yeah. So every object has a certain reflectance, and so you can detect the object by simply measuring the reflectance and say that, okay, if I see this, it's a rat. Are you okay? You feed it into it. Okay. That's for another day. So I've given a lot of examples for those online. They are looking at a lot of images that you are not seeing, or if you are also looking at the Zoom, seeing this. Black and white imagery, because we can take one image and we can revisit the place probably in 24 hours. So the satellite can be just moving its orbit and then come back to the same place. When it comes back, what is the application, Maxwell? If I took a picture of you today and I came back 10 years and I took a picture, what do I learn? I see whether you've changed, isn't it? You say, oh, that so hasn't changed at all. Because I have the original. What does it mean? We can always measure land use, land cover change. Based on time.
So,
yes.
I know these white people, they are moving sometimes what they are.
Of course.
I watched a movie. Like when they take you picture, they can take, let's say, 5 minutes before, or let's say some seconds before and now. But they just take the picture once.
Okay.
Is it with the help of the remote sensor? So
the person took one picture of you, but that picture contains a picture of you in the future, futuristic type of thing. It can predict how you look like in 5 minutes time. I don't get it. Because in 5 minutes nobody will change, nothing will change, right?
Not 5 minutes. Let's say the picture you take with you, and let's say me, this scene right now. But in the same picture, you see that me, I can witness that this is how I stood with you. But in the same picture, you can come that me and you, let's say there is
now a distance.
Yes.
Okay, so that's image processing, isn't it? Image processing can do that. What he's saying is that when you took the picture the first time, you knew exactly your posture.
Yes.
But then you can also generate a new picture.
Yes.
Out of that.
Out of the same picture.
And then you have, so that's software coming in. And so most of these systems, software, there's a processing aspect, there's the analysis aspect. So remote sensing is not just these are like taking the pictures. There's the aspect where we are analyzing. Okay. And that's why I told you from the beginning that now, if a Google can have extracted all the building outlines for most of the buildings here. Are you okay? So that's the news for you. Microsoft is doing the same. A lot of people have done it. Okay, because they can apply the algorithm. Are you okay? They can process it. Is that okay? So there's an analysis part. Are you okay? Remote sensing. When you define remote sensing, there are 7 steps. Okay, all right. And when you look at the 7 steps, it starts from the source of radiation all the way from reflecting and absorption and recording and all that. Then you end up with analysis. If without that, you can't walk into any office and say, I am a remote sensing person, if you can't do analysis. All right. So you are right, that is a possibility.
So whatever the sensor is giving, you have to analyze it and interpret it.
Exactly. Interpretation is also an application. All that is part of it. When you are done, you should be able to use it for something. Okay. All right. So basically, that's that. The key terms is what I want you to use. Don't talk like a layman anymore. Are you okay? When we say remote sensing, remember the terminologies. What are the terminologies? Anybody? All of you mention just one terminology you heard. When you are ready, say it fast before someone else says. Yes.
Electromagnetic.
Thank you.
Sensor.
Sensor.
Electromagnetic wave.
Everybody's going to say electromagnetic sound. X-rays are not used in remote sensing, but it was used to describe the electromagnetic spectrum. So now people are going into the electromagnetic spectrum and they are entering it.
breaking it down.
They are breaking it down. Please don't go.
What about
The whole spectrum is long like this, but only a small portion that's being used in remote sensing. Okay. Any keywords you learned today? Something new word? Hmm? No, you're talking about remote sensing. You're talking about GPS. Okay, it's fine. So these are the things that when I mark your script. Hold on, I haven't asked you to speak. Hold on. Sometimes I can be like that. Don't mind me. I'm like that. That's how I am. Okay, I'm being a bit rude there. So don't worry, I'll let you talk. Go ahead.
Infrared.
Okay, infrared. That's good. That's good. So is infrared. That's also electromagnetic spectrum. So let's be careful. Hey. But really, that's what it's about, isn't it? It's really about the spectrum, the sensor, isn't it? The energy recorded, right? The bands, wavelengths, yeah? That's it, you get an image. The rest is analyzing. So you are right. Most of it focuses on that. But let's understand the process. Exactly. The process. The source of radiation, reflectance, the atmosphere. Okay, guys, so that's basically it on remote sensing. We end the class on mining surveying. We just want to touch on it. Is that okay? Surveying is surveying. If you ask me, that's what I'll say. If you're a good surveyor, survey engineering, I mean, you can just do anything. It's the same calculation everywhere. Is that okay? Vertical, horizontal, nothing more. We want to position, we want to know that if I have this design, yes, there's a pipe going through here. Tell me exactly where it's passing. That's the job of the engineer. Are you okay? All right. Nothing more. That's why engineers always do, fitting things, putting them in. But of course, they understand the properties. Are you okay? They understand methods. What makes mining interesting is that you have to go underground. And underground, your GPS now, you say goodbye to you. Are you okay? See, bye-bye. We'll meet again. You think the signals can go to the earth? So you know that it can't go through, right? I mean, look at that. Look, I mean, rocks. We are going deep. And with these, most mining activities, you drill so many kilometers down. It's not like you are taking a kilometer. Oh, okay, I can see. That's the good. No, it doesn't work that way. It's okay. Go deep. So they have shafts. Go in there and they literally build something like a city down there. You know, if of course you have to carry some food with you. I would need go there and work all day, come back. So you have to eat. Okay. But I remember some miners were trapped underground. In which country?
South Africa.
Chile, eh? You are so good. Give me that. You see, please, when you go in the exam, make it proud. I want to give marks. Shock me, is that okay? So when I'm marking, I'm like, this proves that I was teaching. Please do that for me, all right? If you were in charge of NADMO and then people were trapped underground, what's your plan? Exam question.
Investigate.
You have to investigate. Please don't start that. Policemen are already taking our bribes. Don't investigate.
So you're going for a drawing.
Say again.
Drawings.
Thank you. Now you are talking. What kind of drawings? So you need a certain plan of the underground that matches the surface. Are you okay? So in other words, if there's a mining area, I need to tell that, okay, if you here, you are really at a certain part underground. Are you okay? Of course, I'm interested. If you take under my town, I would like to know which part so that what, in case it's breaking in, then I know when to exit. So it's very important that we do a mine survey. Every survey, you end up with what? A map. So survey and mapping go together. Are we on the same page? All right. So mine surveys are important. Sometimes we need to know, because a lot of people are interested in the gold and the mineral and the resource, they have what they call concessions. So you need to be able to allocate a certain what they call property lines, so that you'll be working with them.
So this is a real question. When they say concession, what does it mean?
It's just a polygon, is that okay? It's a what? It's a polygon. It can be a very irregular polygon, is that okay? Defining where it works. In this case, I want to limit it to a boundary. So my property lines is, so the Mineral Commission knows that I'm working here, but registered with this to take here and do some work. Okay. A grid, talk about a grid. In engineering, grid lines defines a grid. Okay. But once you start working on this, then probably you want to be grading it. So the boundaries where I'm working, concession, are you okay? Have to define by what? Some kind of polygonal shape. Are you on the same page?
Mm-hmm.
Okay. So mine surveys are very, very, very important. For what reasons are they important? For safety reasons. Is that not so? Yeah. So you don't want to have your father stuck underground and we just don't know where was he working, isn't it? The wife will be asking that question, isn't it? Gentlemen, you said where was he working? And you'll be there. We're not sure he went down, but are you with me? Okay. How would you extend your control underground? Anybody? How would you extend your control underground?
By indicating them on the surface.
By indicating them on the surface. Oh, Chris, I think you're sleeping. How would you indicate? How do you extend your control underground so that I can say that okay, actually, when you are down here underground, you are actually here. Are you okay? You see that over there? That's where they are down there. You get it with me? How would you then extend your control down there? Because that's the only way, unless you extend national control, yeah, or surface controls downstairs, work within the same coordinate system. You can never say that this is where they really are. Because in the Chile incident, yeah, when the miners got trapped, they knew exactly where they were on the surface, so that to help the rescue. So back to my question: how would you know where? How would you extend a control? How would you extend control downstairs, underground? Underground. So when you see UG, normally underground is okay. How would you extend control downstairs? Oh, I'm waiting for your answer. In the wrong document. Oh. Yes. How would you extend your control? Do you understand what I mean by extend control? Said, I'm your examiner now. Don't forget. How would you? What is extension of control? What is extension of control? What does it mean to extend your control? What's control? Please don't do this to me. We are recording this for you. What is extension of control? Because some of you have missed the previous lecture, isn't it? On horizontal and vertical control. So they are scared. Even though they know what it is, they are not confident to come out before I say, hey, you were not there. Okay. So we have horizontal and vertical control. Is that okay? These are simply pairs of numbers, okay, or triplets of numbers that define where you are planimetrically. Okay, so location-wise, the boy is here. Are you okay? So you'll be looking there, isn't it? Then you'll be looking up and down. Maybe he's hanging up. Okay. I'm talking about in a game, when you're playing a game. When you're designing a game, sometimes your character seems to have flown up into the sky. It happens. Okay, guys. So we need to know that mining is regulated. Is that okay? So you just can't get up and just do anything because you end up killing people's fathers and uncles, and brothers. So we won't let you just do what you like. One of the things that is required is what? The plan. Are you okay? Right. So we need it. The shaft is interesting, isn't it? What's the shaft? What role does the shaft play? Christ, you haven't spoken a lot today. What role does the shaft play? Do you know what a shaft is? Okay. Have you been to Confanochi Teaching Hospital before? Okay. Have you seen a high-rise building before?
Yeah, like
even this one. So you can have a lift machine. It's also like they refer to it as a shaft.
It's an MPE.
What is it? What is that?
National Petroleum Authority.
That building. They have it in there. It's significant. Are you okay? All right. So where you find the gold resource, are you okay? From the assay results. And what's assay? Assay is like kind of a lab test to find out if there's some gold in a certain rock sample. Are you okay? They do what? That's what they do. They actually do some sort of exploration first before they do the mining. So when someone says he works at the mine, find out it may be the exploration. But even that is becoming, it's quite lucrative. Are you okay? Exploration completely explore because they find it, isn't it? They find the results and they tell you that you have this cubic meters of mineral in here of gold. So are you interested? So okay, we are interested. So stakeholders come in, stock people who have money, they come in. So say, okay, explore it. How much are we going to make out of it? Are you okay? Then you carry on. All right. So subsidence. What's the word subsidence? What's the relevance of it in mining? Subsidence. When someone said the risk of subsidence, as an engineer, you can't help it. Then we won't employ you or we fire you. Okay, you call it before the public accounts on it. Subsidence. What's the relevance of the word? So it works like this. Guys, I think you are tired. I'll lose the class. So there's resource to be sitting down. Okay, that's the all. Are you okay? Okay, we need to go in there and dig it, isn't it? Do that. All right, so we have to find a way to get in there via the shafts. Are you okay? Now, after digging through, are you okay? Find a way to actually assess it. We can't only keep on going vertically down. We need to also descend and start working. Are you okay? All right. So in here, you can have a whole setup of rails, beam belts, are you okay? Reinforcements to avoid the whole thing collapsing on you. All right. So now, what's the risk of this thing breaking in? Based on this, bearing capacity and all that. Yeah. Right. So now, it's a risk of what? Subsidence. The big web in local balance, right? You say big web, so now the surveyor has to transfer coordinates up here so that we know that if people in here go stuck, we probably be able to know this is where they actually go stuck, where the big good trees. Because this is a section through the ground. Are you okay? But on the surface, in the plan, this is a plan. This is a section to explain to you how it works. But this is the plan. Okay, so about the plan, I need to have the underground. I need to see the underground, all that is going on in there. I don't. So this is kind of like some sort of plan. I have some lot of things are going on. I need to extract, carrying all the ore out, and then refine it. Are you okay? Because position is very important, we just want to ask, we want to coordinate this, for example. So the mine surveyor's job is to tell us this is exactly where this point is, where we start having this tip and output. Are you okay? In a discussion, you are at a table and we have the discussion. This is where are you okay? every day there should be a review meeting where you talk about this. Your job as a surveyor on the team is to now assure us that we know where we are. Okay? Don't kill us before we know. The guy called us, but we didn't know. How do you transfer the coordinates? You guys said it's a benchmark application, which has coordinates in the national coordinates down here. The Z is important. I'm going down. The Z is important. Are you here? Once you start going down, the elevation is important. How deep you are. Are you here? All right. So the transfer or the extension of the control is what I was asking the class. How would you extend control even on the surface as a class? You need to understand that.
Yeah.
And then when we move from there, in our last class, remember our last class, spend a lot of time on that. When we move from there, then someone now asks you, now extend it underground. Are you okay? And this is where a student starts thinking, hey, how am I going to do? Because surface I can't extend. It means you are not qualified. How do you extend control of the surface? Methods. I want to hear methods. Method. How do you extend control? X, Y coordinates. How do you extend them on the surface? From this is our Plaku road, isn't it? How do I extend control all the way to the Winneba road? How do I extend it? Yes, Said. If I mention him, you are even blessed. Said. How would you extend? What is a control again? Christ, what's a control? What's a control?
Temporary control.
Even today, you could have said it means you are tired or your mind is not here. You have coordinates. It's a place, it's the same point where you have the coordinates. So you have a point A. That's A, Y, A. You can do the coordinates at a point in this class. So these coordinates, physically on the ground, you will have some monuments. I agree.
Yeah.
So this, you can call it a station. Okay. The word control is also used. And I actually say that once you know control, it controls the movement. All right. And we have horizontal control. Why do we say that sometimes you have the X, Y, then you don't have the Z? That is why we talk about horizontal and vertical control. Why? Because the methods used to transfer or to obtain your Z height is no bit different from the methods used to extend the SY control. So this is traverse. Traversing allows you to extend control. Are you working from the goal to the heart? Then this one is leveling. Are you?
Yes.
And leveling, rise and fall. Height of coordination is finished. And when you finish, you need to work out the disclosures and the errors and find out that the method was accurate. Are you okay? All right. I know you will sit down and read through it, but I can assure you that you will not give me any funny answers. I will not spare you. I'll not spare you because I've given you all the chance. I've said something in the class, something I've taught last, I mentioned in class. People are pretending like
So it's like,
I'm just
how the person like that, when you have the control, use
now actually use what we call the waist back method. So the waist back method allows you to suspend in the case where you actually have one shaft. Transparent is not easy. Transparent on the ground requires a backside and you can't position. Then you measure to a day 10, then you get the next one. All right. Now you are right there. This is your back. You can't tell it to the light to go. You see. Actually, you see the whole thing. So if you are not careful, someone who doesn't come for lecture like this, the answer he will give me. So if God doesn't help me, 7/100, I'll have to do the best. Because it means you didn't come for the class. It's not possible. So you have to listen very carefully. You have to use some sort of suspended, steel, okay, that goes down, that suspends all the way down. And then you now actually get the Z, okay? Meanwhile, you have the Z on top, okay? So by just extending like this, you can now have 2 points. So the shaft is big enough to help you actually establish some sort of, just change the Z, same Z, okay? Change the Z, but the same XY, okay? But if you have, if this one is a bit small for example, but if you have 2 points in there, you could literally extend them in there and then start working out a triangle. The reason they call it a triangle is because if I had a shaft of figures, okay, and I could extend these wires down, okay, I'll now have points A and B underground. Are you okay? Then once I get A and B, now I can start having points C, measure distance points, get the bearing. Are you okay? And then with this triangle, I extend control underground. Okay, Chris, what's your understanding of this one?
We use examples of
Oh, we've talked about this before.
yes.
Oh no, that's under extension, actually setting out a trench, isn't it?
But it's not similar. Transferring the coordinates to from.
Not quite, because with that one, you need to site. I can use a site wheel. I use a site wheel. You measure it. So there's a movable, square like that you actually do. So depending on whether it's below or above, you have not reached the height. For this one, this is the surface. Okay, and then you have to extend, suspend these things. These are actually steel. These points are going to underground. Now, if you know the coordinates of the surface, we can then have the bearing of this line, okay? And then have another point C to form the triangle ABC. Now, since you know this bearing, you can now find this one. You can measure that. Bearing, angle, yeah? Establish this control, and then carry on, okay? And then detail underground. I don't know why you don't get it. Every point, let me tell you something, any points, so in AIT, like the coordinates here, if this was done by an architect, let me give you a typical, every engineer should think very fast. Think very fast. Architects don't draw, they don't do these windows separate from the next floor. Likely, this corner is actually aligned the window down there. That's one secret. So when you're making a mistake, start thinking about the decimal designs. You don't have time to draw this separate. If you've done AutoCAD before, you don't have time to make this one separate, make the next one different dimension. You don't do that. Textbooks. Are you okay?
Copy.
So it's very important to be very practical when it comes to this. So this is a way back. Obviously, there can be other methods. Are you okay? Yeah, it has its own advantages and disadvantages. When the points are too close like that, it's going to errors. So you have to know that that's a disadvantage. Okay, so because of all the requirements of the mining, we need to do.
So I'm asking a question based on the method. The known coordinate, is it set on top of the shaft or you transfer it from somewhere? Yes.
Is this exactly? So let me tell you something about engineering. I was never taught that. I was taught reflectors that you put them on a tripod. Tell you what engineering is about. A lot of things being taught in class. In your own situation, you have to design your own thing. So I know this is possible. You can have this. I just want even on border to even tell you exactly how this can be done. Yeah. Once you are on top, someone says set up this coordinates. I'm holding it. Any good engineer can hold like this and you give me the coordinate that I take. And when I do this, you can give me another one. That is engineering. Are you okay? You think outside the box. I was taught reflectors are mounted on tripods, but actually you can make reflectors as small as this. And just put it there and you get it. So this one you won't be caught by it. So it depends on your situation. And with engineering, it seems anything is possible. Are you okay? So look at your situation. See what are the problems. That's when an engineer comes in and say, okay, this is my design, this is my approach. So makes you an engineer. Are you okay? Right. So I think the Chilean one, wow, the people were, I was so proud of those who rescued them. Are you okay? They didn't die. But are you aware a lot of people have died? Mines collapsed, all that. And at a point, they said there was some, like some water down there underground. It's like some kind of pool of water. And they thought that's where they were now. And if you follow the whole thing, oh, it was just fun. It was just fun. Anyway, have you done attendance list? Please do it now. Christ, are you there? So please read. I just dropped the mindset PDF. Just read the PDF, the PowerPoint, and you'll be fine. Is that okay? My mining is not really environmentally friendly, is it? We all know what happened at Apiate, right? Apiate. Environmentally friendly. Waste rock tanks, waste. They use arsenic sometimes to do some processing, and that arsenic can cause Buruli ulcer. Can you imagine that? Oh, so guys, that's it. Thanks so much.